Hyperbolic functions are similar with trigonometric functions, although they have been derived using the hyperbola instead of circle. Check out how to get the derivative of these functions here in differential calculus. The derivative of hyperbolic functions follow the same pattern as trigonometric equations with slight changes. The derivative of hyperbolic sine is hyperbolic cosine of the angle times the derivative of the angle. Just the same, the derivative of hyperbolic cosine is hyperbolic sine of the angle times its derivative. Next is the derivative of hyperbolic tangent x, which is the square of hyperbolic secant of x times dx all over dx. Then we also have the derivative of hyperbolic cotangent x, which is negative square of cosecant x times dx all over dx. The next is derivative of hyperbolic secant x, which is negative hyperbolic secant x times hyperbolic tangent x times dx all over dx. Then last is the derivative of hyperbolic cosecant x, and that is negative hyperbolic cosecant x times hyperbolic cotangent x multiplied by dx all over dx. Take note that the range for the negative derivatives are now placed on the latter half of the functions instead of the alternate allocation in trigonometric functions. However, the pattern of pairings is still the same. The first two have simple opposite pattern. The next pair is the squares, and the third pair has double trigo. Here are some examples. First is with the function y as hyperbolic sine of 4w. Checking on the pattern previously discussed, we can extract out x as 4w, and x prime is 4 times w all over w. That is 1, so x prime is 4. Thus, y prime is hyperbolic cosine of 4w times 4, which can be arranged as y prime equal to 4 times hyperbolic cosine of 4w. The second example has y is equal to the hyperbolic tangent of the binomial 1 minus 3r. Tangent is the pattern with squares, so take out x once more. In here, x is 1 minus 3r, and x prime is the derivative of 1 minus 3 times the derivative of r with respect to r. The derivative of 1 is 0, because this is a constant. The derivative of r with respect to r is 1, so x prime is negative 3. Place these parameters in the y prime equation to get the square of hyperbolic secant x times negative 3, or that is negative 3 times hyperbolic secant squared of x. Example 3 has the equation y is equal to the square of the binomial 1 minus w times the hyperbolic sine of 2w. We need to use the product rule for the two terms multiplied. So we have y prime as the first term times the derivative of hyperbolic sine of 2w, plus the second term times the derivative of the square of 1 minus w. With the derivative already focused on specific terms, we can check that the derivative of hyperbolic sine 2w is hyperbolic cosine 2w times the derivative of 2w. Just the same, the derivative of the square of 1 less w is 2 times the quantity of 1 minus w times the derivative of the binomial, as we work with the power rule. This can be further simplified as the square of 1 minus w times the hyperbolic cosine of 2w times 2 with dw all over dw, plus twice of the binomial 1 minus w times the hyperbolic sine of w with the derivative of 1 minus the derivative of w, which are taken as 0 and 1 respectively. So the final y prime is twice of the square of 1 minus w multiplied by the hyperbolic cosine of 2w less twice of the same binomial times the hyperbolic sine of 2w. Next is the derivative of y is equal to e raised to negative x times the hyperbolic cosine of x. With two terms once again, we use the product rule. So we proceed with y prime as e raised to negative x times the derivative of hyperbolic cosine of x plus the hyperbolic cosine of x times the derivative of e raised to negative x. The first derivative has hyperbolic cosine pattern, and the second is with the exponential function, where u is negative x and u prime is negative 1. So, y prime is e raised to negative x times the hyperbolic sine of x times dx all over dx plus the hyperbolic cosine of x times e raised to negative x times negative 1. Finally, with a little arrangement, y prime is e raised to negative x times the hyperbolic sine of x minus e raised to negative x with hyperbolic cosine of x. Example 5 is with r is equal to the arctangent of the hyperbolic sine of x. Take note of the pattern for the derivative of arctangent again. So identify u as hyperbolic sine of x, and its prime is hyperbolic cosine of x times dx all over dx, which can be simplified as hyperbolic cosine of x. Plug u and u prime into the arctangent derivative pattern to have r prime as the hyperbolic cosine of x over 1 plus the square of the hyperbolic sine of x. Another example has r is equal to the ln of the hyperbolic sine of 3w, which is a logarithmic function. So, the rule to use is u prime over u, whereby u is hyperbolic sine of 3w, and its prime is hyperbolic cosine of 3w times the derivative of 3w, and this can be reduced to 3 multiplied by the hyperbolic cosine of 3w. R prime is the ratio of 3 times the hyperbolic cosine of 3w with hyperbolic sine of 3w. Now, with the basic trigonometric identity that cosine all over sine is cotangent, r prime can be shortened as 3 times the hyperbolic cotangent of 3w.